Welcome to our Math 154 videos. This video is going to be talking about the first and second derivative test, and we are going to find the local maximums and local minimums of this function f of x by using both the first and second derivative test. So here's the first derivative test. We have if c is a critical number of f, so that means makes the derivative 0 or the derivative is undefined there. And if f prime, the derivative, changes from plus to minus at the critical number, so a derivative from positive, meaning the function's increasing, to negative, meaning decreasing, would give us something that looks like this, which is a local max. And number 2, if f changes from minus to plus, so minus, that means the derivative is negative, so the function's decreasing, then the function changes to increasing, then we have a minimum. Alright, so that sort of makes sense if you draw the picture. And if f prime does not change sign, there is no maximum or minimum. So that would be something like the derivative hits 0, and then we keep going up. Okay, so there's a derivative of 0 right here, but we didn't really have a local max or min there. So let's go ahead and try that with our function f. So first we need f prime to get the critical numbers, and so that's going to be 5x to the fourth minus 5, or we can just factor out a 5 and get x to the fourth minus 1. Alright, now where is this critical? Well, the only numbers that make x to the fourth minus 1 0 are plus and minus 1. So those are the critical numbers. Alright, because anything we put in there and raise it to the fourth power, it's not going to equal 1 unless it's plus or minus 1. So those are our critical numbers. Well, now we're going to make a sign chart of f prime, and we're going to look at what happens when f prime is to the left of negative 1, and when it's in between negative 1 and 1, because these are our two critical numbers, and what happens to the right of 1. Well, to the left of negative 1, say something like negative 2, when we raise that to the fourth power and subtract 1, so like 2 to the fourth power, that's going to be 16, minus 1 is 15, times 5, that's clearly going to be positive. So, to the left of negative 1, our derivative is going to be positive, because no matter what we put in there, when we raise it to the fourth power, it's going to be positive, and it's going to be larger than 1. So when we subtract 1, we're still going to be positive. So that's good. Now what happens between negative 1 and 1? So something like 0? Well, 0 to the fourth minus 1 is negative. So in between negative 1 and 1, when we raise that to the fourth power, it's going to be something smaller than 1. So when we subtract 1, we're going to get something negative. Now on the other side of 1, when we put something bigger than 1, like 2, again, 2 to the fourth minus 1 is the same as negative 2 to the fourth minus 1, because that's an even power for the 4. So we're going to get positive for there as well. Alright, so what does our first derivative test say? F prime changes from positive to negative, we get a max. F prime changes from negative to positive, we get a min. So negative 1 is a local max, and 1 is a local min. And those were our only two critical numbers, so those are the only two that we have to check. Now we're going to try and do this with the second derivative test. Alright, so here's our second derivative test, and notice I've written down our critical numbers that we found in the previous section, because those are the same, because we have the same function. So the second derivative test says if the first derivative is 0, so that means our critical points we found here, plus or minus 1, those were both points where the derivative was 0. And if the second derivative is greater than 0, And so the second derivative being greater than 0 means the function is concave up. So a function that is concave up looks like this. So then f has a local minimum at c. Alright, so if you forget what that means, you can just draw the picture. So a positive second derivative means concave up. Then number 2, the second derivative less than 0, means we have concave down. So it looks like that. So then we would have a local maximum at c. Now notice through both of these problems, our function f is continuous. Okay, so that's also pretty important that we have a continuous function, that the first derivative is continuous and the second derivative here is continuous right around these points c, so that we can actually do these evaluations. So we had the first derivative again was 5x to the fourth minus 5. So the second derivative is just going to be 20x cubed. Alright, now to figure out if the second derivative is positive or negative, we actually have to plug in the critical numbers, because it says f double prime evaluated at c. So our critical numbers are plus and minus 1. So we're going to plug those into f double prime. And f double prime of 1, that's just going to be 1 cubed is 1 times 20 is 20. And then negative 1 cubed is negative 1 times 20 is negative 20. So f double prime of 1 is greater than 0. And if it's greater than 0, that means we have concave up. Concave up means there's a min. So 1 is, x equals 1 is a local min. And then the other way, we have less than 0. So for f double prime of negative 1, we're concave down. And so that means x equals negative 1 is a local max. And those are the same things that we got by using the first derivative test. So the first and second derivative tests really tell us the same thing, just sometimes you're going to notice that the first derivative test is going to be easier, and sometimes the second derivative test is going to be easier. So it's up to you to decide which one to use. In cases like this, our second derivative was pretty easy to calculate, and it was simple to plug in the places where the first derivative was 0, so it made a lot of sense to use the second derivative. If that's going to be too complicated, it might be easier to do the first derivative test. And that's it for this video.